This conference will now be recorded.
You get, you have to give a student pass or fail, okay?
Yeah.
Or you have to calculate percentage. Okay, let us assume you have to tell two things.
Okay.
Number one, whether he passed or failed, and number two, percentage,
Okay.
right?
Mm-hmm.
So look at the last new layer.
Then
Last
there
layer,
will be two. Yeah.
you need two. One will
Yes.
say pass or fail, another will say percentage.
So it does not have any dependency between pass or fail or percentage?
Oh, there is, but the output must come from two neurons. Okay.
Mm-hmm.
One neuron gives you only one thing.
Mm-hmm. Got it.
Okay. That is number one. Now, can you combine to get values from one neuron as tuple or set? Yes, you can. Okay. So when I'm telling you, is it mandatory? No. But is it practice and most feasible solution? Yes. Okay. So almost all the models you will see, if you need two outputs, last layer will have two neurons.
Got it. Yeah. Now I'm okay with that, because that was one of the doubt which I was having from yesterday's session.
So come to first layer. Okay.
Mm-hmm.
Come to first layer. Whole idea why our classes are different, because we interact, we talk. Okay. If you're asking questions, I can tell you anything. If you don't ask me questions, I will go through them also. Okay. Now, the first layer is, let us assume that you get a student appear in 5 subjects, right?
Okay.
And same copy is sent to 3 examiners, not one examiner. So that you will take average of 3 and give the result. Do you understand?
Yeah.
And students are not penalized because somebody is very harsh examiner, somebody is very lenient examiner, like that. So every copy is sent to 3 people. Okay?
Mm-hmm.
Do you understand?
Yes.
Every copy is sent to 3 people. And finally, you have to give pass or fail and average percentage. Only 2 layers are there. Okay?
Okay.
So one student appear in an exam. How many copies each examiner will get?
5 copies, right? 5 subjects.
No, 3, 5 subjects. So 5 papers every examiner will get, right?
Yes.
Yes.
Suppose he gives equal weightage to all of them. How many weights he will have?
5.
5. Yes or no? You call that
Yes.
average? You call weightage? What he is going to do? Each examiner, for one student, he is going to say 0.2 into subject 1, 0.2 into subject 2, 0.2 into subject 3, 0.2 into subject 4, 0.2 into subject 5. Right?
Yes.
That is the way he will calculate average. Right?
Yes.
And passes the value to both neurons in last layer. Clear? Second examiner will also do the same thing. Third examiner, all 3 examiners passes the values to first neuron in last layer. And that takes average of all 3. And if average comes below 50, he says fail. Above 50, he says pass. Second neuron takes all 3, makes average and passes average value to the final output. So I have taken very simple scenario. One student appears in 5 papers, 3 examiners are there, all 3 of them evaluate all 5 papers, right? and they have weight for each paper. 0.2, 0.2, 0.2, 0.2, 0.25, right? Are you people able to understand?
Yes.
And then they pass, all three examiners will pass the marks to both neurons of the last layer. First neuron will say pass or fail. Second neuron will just calculate the average and give the output, right?
So how it differentiate neuron, like I need to pass and fail, and other neuron will say I need to calculate average.
Yeah,
How
there
they know?
is a function you will say activation function, remember?
Yeah.
Activation function will be what? First has activation function, calculate the average. Average is below 50, say 0, above 50, say 1. Do you understand?
Yes. Yeah.
In last layer, first neuron gets how many outputs? Last layer. Previous layer were
One.
3 examiners. Previous layer, 3 examiners were there, right?
Yes.
So in last layer, the first neuron gets all 3 outputs, right?
Yes. As
So he
input.
will
Yeah.
get 3 outputs. First thing he will do, he will multiply the weight with 3 weights with 3 outputs. Let us say 33, 33, 33 for simplification. He can change it, right?
Yep.
In last layer, 1 neuron is he will multiply the weightage with each examiner's marks. Are we clear or not? Each examiner is evaluating 5 papers, but he will not give 5 values to the last neuron. He will do average or whatever, and he will give only one value to the last
Like
neuron.
arithmetic representation, so that it would be easy for like
Yeah, no, I'll have to put my this one. It will take a couple of minutes, but in the meantime, you can keep discussing.
okay.
So what I'm saying that each examiner is doing what? Evaluating how many papers?
5.
Five?
First layer 5. Yeah.
Each examiner. Okay. And last layer, let us say tabulator. Last layer, there are 2 tabulators who just tabulate whether somebody passed or failed. Clear?
Yes.
Yeah.
So it will be only 2 neurons at the end.
One neuron gives percentage, another neuron says pass or fail. Right? Are we clear?
Yeah.
So now what happens? Look, each examiner is evaluating 5 papers,
Yes.
Yep.
but he is not giving 5 results to tabulator. He is doing average of all 5. He can do simple average, he can do weighted average, whatever he does. Okay. So you see, the student is there. What does he do? He gives exam P1, P2, P3, P4 and P5. These are examiners, right? Each of them get 5 values. Yes or no?
Yes.
Yes.
So what they do? They give marks. Suppose this guy gives marks 70, 80, 85, 35 and 90. Right?
Yeah.
Yes.
And weight, he gives different weights. 0.1, 10% weightage, 30% weightage, 40% weightage, 5% weightage, and 15% weight. Right?
Yeah.
all papers are not equal.
Yes.
Do you understand?
On the credit of the subject,
Pardon?
is it based upon the weight of the subject we are providing the weightage, or the
Yeah,
credit?
this is way. The examiner is thinking that this is more important, this is more important than this.
Okay.
This is not at all important.
Mhm.
You will have some elective papers, right?
Yeah, yeah.
I know all technical people don't study literature and history, right?
Yeah.
So examiner is also having preference.
Okay.
He calculates the average, say 65 comes, right?
Yes.
Now what happens?
This is passed to second layer of the first neuron.
65 is passed to second layer, right?
Yes.
Say 70 is passed to the second layer, 30 is passed to second layer, right?
Yes.
And same value is passed to this neuron also. Yes or no?
Yes.
So this guy does say simple average. So what is 0.33, 0.33 and 0.33? This guy doesn't do simple average. 0.25, 0.50 and 0.25, right?
Yes.
What is his function? His
Awesome.
function is fz 0 if z is less than or equal to 50. 1 if z greater than 50. This you have to define.
Okay.
You understand? This function you have to define. And fz equal to z. Simple. Don't do anything. Whatever calculation is there, you pass it. Right?
Hmm.
So roughly this is 15.5 and you have 35 and 7.5. So 15, 7, 23 and 35 is 58. This is the one output, right?
It's just the average. It's like 135 divided by 158.
No, no, 25%, 50% and 25%.
Okay, okay.
Okay? Whatever, calculation may be different. This is 58, and this is also 58. Do you understand? Is
Yeah.
passing.
Yeah, got it.
Okay. And this guy, what he is doing? He is taking average of 3 because all weightages are fine, right?
Yeah.
So 165 divided by 3, that is 55. So 55 greater than
1.
So F55 equal to 1 and he will give you 1. Do you understand?
Yes.
This is the way neurons work, right?
Okay. But for the second one, it will be going as a 58 only, right?
Pardon? No, no, no. Second one, two things you wanted. So two neurons are there. One neuron is giving 1,
And the second one is giving 58.
58. You wanted two things. Two neurons are giving you two things.
Okay, okay, got it. Yeah.
Both neurons are doing different jobs.
Mm-hmm.
Okay. Can you
Yeah.
combine? Yes, you can combine. Should you combine? No.
We couldn't combine it.
You shouldn't combine because beauty of neurons is that they do one small work and they do well.
Okay.
If you combine a lot of things, you are combining function of neurons which can be split, right?
Yes.
Why would you join and complicate?
Even if it is not combining, both of them passed, right? Here.
Both of them means what?
It's
No,
for
no, no.
one student. This is for one student.
Second one is 58 doesn't matter pass or fail.
Okay.
That's the average.
58 is percentage. Second one is not bothered whether 58 is pass mark or not.
Okay.
First one is bothered, right?
Yeah.
First one has to decide pass or fail. Second one is just informing that you got this number.
Okay, okay, got it.
Yes or no?
First one is like
Just like in our result, we have right pass and the percentage.
Yeah,
There
two
will be a
neurons.
status as
yeah.
a pass, status as a fail, and there will be a percentage, right?
Yeah.
Okay, got it.
Somebody
Yeah.
is deciding
Such a-
cutoff mark, right?
Mhm.
Yeah.
And somebody will be giving individual paper marks, and somebody will be calculating percentage. The guy who is deciding that cutoff will be 60% or 30% is not the guy who is doing. He is providing a function here.
Okay. It is the value will be coming from one student, but it will be determined by two. The results will be determined by two different neurons.
Because and suppose another student 2 comes,
Okay.
right? Same cycle will be there. A student 3 comes, same cycle will be there.
Okay, got it.
Yes or no?
Yes, yes.
And then they will compare with actual result, right? This is
Yeah.
machine computed result, right?
Yeah.
So data will be like this. To train machine, you will give a student marks, pass, fail, and percentage. 3 things you will give. So 100, 90, 45, 65, 30. 1, 85,
Okay.
35, 49, 50, 105, 75, 0, 45. Like this. This is actual data, right?
Okay.
What machine will do? It will take this and try to have a formula. But this have a formula.
Mhm.
Do you understand? Now fz equal to 30 or less is 0 and greater than 30 is 1. That also you do not provide. Why? This
The
machine
fail,
has to.
yeah, the
The
fail says
machine,
that 45 is 0. So,
machine has to guess.
uh-huh.
You understand?
We have to define function, right?
No, you don't have to define.
Okay.
If you define, then what machine will do?
So we just need to provide this parameter,
Data.
right? Activation was there, right?
No, activation function, what I told you is misleading. We'll talk about. Okay. Sometimes what happens, I give very good example of. How many of you are familiar with this?
Force is equal to mass
Into acceleration?
acceleration.
Yeah.
Yeah.
That's the question.
This is horribly wrong.
Tagore, I didn't get the last function you told. Can you explain to me? So it couldn't like yeah, this
Yeah.
one instead of less than or equal to 30. So
Let us look this way. This is your input or output?
this is our output.
This is
Output?
input.
Output. So, see, training it will give both. But ultimately, when machine has learned, this will be your output or input? After training the machine model, what do you expect? You will give this and you will get this. Yes or no?
Yes.
Yes.
So this is your input and this is your output, right?
Yes.
Yes or no?
Yes.
So, yeah, first column is input and the second and third one is output.
If you are giving output formula also, what machine is doing?
Yeah, that we couldn't give it, right?
You need not give. You will give this. Machine will evolve a formula. I told you this formula also you don't need to give.
Yeah, I got it. Yeah.
Everything machine will do. Why I keep on saying machine is learning is dangerous because
Yeah,
you don't.
but I got confused because you have given another formula there, so that's why I just wanted to clarify.
Yeah,
So we
I
don't need
told you. I told you in manual model how people will decide,
oh,
right?
okay.
Pass and fail. Somebody has to tell 30% pass and 40% fail. Yes or no?
So
But
basically,
if-
we need to. Yeah, go ahead.
yeah.
Thakur.
No. Go ahead.
So basically, we need to train neuron to give such output. So we have to provide before actual into function. We
fail.
need to provide this
Pass
data and pass, fail, or this one, right?
percentage, and you don't tell how it was computed.
Right. Okay. So it will evolve. We need to just provide this input data and whether it is pass or fail, just like key value pair, and then it will evolve itself to give this formula or percentage and
Exactly.
pass and fail. Okay, got it.
Exactly. And this is why it is dangerous. Okay. Now you give pathological report. Somebody needs surgery or not. You give past patient records. It will evolve a formula. Okay. You give past molecular report and tell this new molecule will be effective or not. It will develop a formula.
The formula will be evolved automatically.
Yes, exactly.
Okay.
See, your data is not constant. Your model algorithm is not constant.
Okay.
You still believe that a human can compete? I have serious doubts. Just now I was watching a BBC report. Somebody is claiming that he came to know about whether chicken or egg. Yeah, I promised I'll not tell you people quantum physics, but BBC is putting a report which is horribly wrong. I don't understand what the standard of BBC is now. Once upon a time, BBC was for the truth. Okay, you will rarely see propaganda. It is not that BBC was not doing propaganda. Today, BBC has become like Indian media or Fox News. Okay, they are just peddling lies. What he told that chicken and egg, which came first? So it is taking quantum physics and told that chicken and egg both came together. Horribly wrong.
Horrible.
Okay. I understand. I don't see Einstein and or no, it is what is that? The father of quantum physics. Here you see, who is father of quantum physics? I keep on from. So he told that if you understand quantum physics, you don't understand. Perhaps Richard Feynman told that if you claim to understand quantum physics, you don't understand. Though this is attributed to Einstein also. So with that caveat, I understand quantum physics better than. What quantum physics says you? That you have this vector space in Hilbert space, you are there. You multiply by any unique complex vector and all states are possible. And that is super state. And somebody didn't know ABC of physics, created a report, he is telling you chicken and egg. But yeah, it is horribly wrong. I read at least one book on quantum physics every year. Okay. So today also, right now also, my son and I are going through a book. Okay. No, that's it. I forgot his name. First propounder of quantum physics. The guy who's in writing was bad. Who's what? Quantum physics gone. Yeah.
Niels Bohr.
Niels Bohr. Thank you.
Father of quantum mechanics.
Okay.
Our first person to quantum.
That is what I asked you. My son doesn't agree on anything. Okay. I teach him, but oh, thank you. That I asked you. I forgot Niels Bohr.
अभी मैं क्या करूँ वो
No.
Dilbert
Yeah.
Source वाला देखूं।
No, you should watch this.
Okay, तो मैं ये खा के आता हूँ।
Okay. Now, what happens is, let us go to coding. You all are ready for with notebook?
Yes.
Yes.
Good. If somebody is not ready, please go there and do it. So yesterday we were doing here. So I'm going to start from the beginning. You have to run again. And I'm not very sure you people are enjoying not, but I'm enjoying this class because you people are asking questions. You people are enjoying or not, I don't know. So
I'm also
what-
liking it.
So the same program, right? Yesterday's the
yeah,
Okay.
so we are going to put deep learning model. We did not put yesterday, right?
Yeah.
So what I'm going to do is I'm going to give you code. The whole idea is that we will change the neurons. Okay. I have opened 2, 0, and this is there, and this is.
So yesterday we started two dense layers, one with 64 and one is 32. And then next we were discussing about having a single target count.
We wrote that.
Yeah, we wrote
Yes.
that, but we didn't execute that the target count.
Yeah, the
Yeah,
64.
I'm not getting that data. Can you somebody show me the screen?
Yeah, I can.
Because who is going to show me?
Yeah. So can you allow me to show?
Rajesh?
Yeah.
Yeah.
That was
Because-
001, 002 machine learning overview.
Yeah, I was trying, but I'm not getting that.
This is the one. Import the TensorFlow as TF.
Hold on,
Yeah.
let me go to that folder. Okay.
We added until this, but when
We
while
have so much data now, we get confused. Yeah. So I did not write ReLU perhaps, so I lost somewhere. Hold on for a second. In this, I did not change. Yes. And I did not change in that, and I lost somewhere. Okay, I might not have saved. Okay. So basically, you people have already written sequential, and I have not written, right? So what we are going to do is, I'm going to do is publish talks. I'll have to copy. I don't write code. So you can take solace from my way of working, that I copy everything and you can copy everything. And that is the way I write code. Okay. So I don't even try to. So you already wrote this, right?
Mhm.
Yeah.
So I'm copying and pasting. Okay. Sorry. And see, objective is that first time you did classical machine learning model. Classical machine learning model was this. Okay. Now we are doing deep learning. Classical machine learning model is basically single model working 1 or 2 times. Deep learning, what happens? Same model is
I
repeated.
have a question there. So you told like a classical machine learning model works 1 or 2 times. But yesterday in one of, I think you said like it can work 1 time or it can work multiple times within itself, right?
Yes, exactly. So we will talk about that, but the deep machine learning, not only multiple times, but multiple models. See,
No, let's talk deep machine learning, it will work with multiple models multiple times. But classical machine learning, it will work within one layer multiple times, right? Can be one or multiple times.
okay, let me put this way. Suppose you are playing game of cards or game of tennis. There are 5 sets, best of 3.
Are you
Yes or
sharing?
no?
Sorry, I didn't get you. Can you repeat?
No, I'm not saying so.
Yeah, you please share. I think it's my screen.
Now you can see, right? Yes or no?
Yes, I can see.
Yeah. Yes.
Tennis, you have 5 sets, best of 5. In chess world championship, you have best of 12. Boxing used to be best of 24. Now best of 12. Why they are? Because in cricket you have test series. Yes or no?
Yes.
So that you repeat same thing over multiple times and then you decide which team is superior, right?
Yes.
One time may be fluke, right?
Yeah.
One time may be fluke. So tennis when you play, okay, this is 1-to-1 and this is classical machine learning. Okay, say football, that you can say deep learning. Why? Football is a team player, right?
It's team game. Yeah.
And tennis is individual. So that is the difference. Like boxing, you can say classical machine learning, single neuron, and they are, oh, boxing is only one. Okay, so, but you can have tennis, best of 5, right? You can have chess, like that. So basically, deep learning and classical machine learning, the number of neurons which are in their own capacity, perhaps single individual classic models, though they are not classic models. Okay, these are early days, so I'm using a lot of wrong terms. Please don't quote me. Okay, after 1 month you will start quoting me because I have to explain you a lot of things and I have to tell things which are not right. Like I told you, F equal to MA is wrong, horribly wrong. Okay, this is not correct formula. And all of you believe it is correct, right? It is horribly wrong, I can tell you. Okay, I wouldn't teach anybody that. Okay, so coming back to, let us understand that we have added layer. So you people can run up to this from beginning and we can get started.
Okay. So beginning is like from import to TensorFlow, right?
From beginning you run. From the beginning, because you need data also.
Okay.
Yep.
And then we are doing
The target count is not defined.
Okay, target count is not defined. So how will we define target count? You see here, x dot shape is there. Okay. So let us try here x dot shape. Before doing TensorFlow, create 2 cells and print here.
Shape. Okay.
Okay. Now x has 2 values. X equal to has 2 values. What is that? 506 and 13. I have not taught you Python, so I'm going to tell you something. The bracket 506 and square bracket 13 both are same, except you cannot change this. If you want to change this to 507, it will give you error. If you want to change this to 507, it will be okay. This is called list and this is called tuple. For the time being, it doesn't matter. You need not bother about. But this is tuple. You cannot change the value. But remember that if
Tuple
we have five,
kind
yeah.
of okay, we couldn't change the value, right? It change is like we couldn't update also in the tuple.
You cannot change. Don't worry about that. We are going to read about tuple. I just wanted to tell you that sometimes you will see this and sometimes you will see this. So don't worry. Okay. Both are one and same except not changeable, changeable. Okay. You need not remember all these things. Okay.
So right now what is the tuple, right?
Yeah, this is tuple.
Okay.
This is list.
Okay.
But I don't want to inundate you with a lot of terms. So only thing is that this is a list and this is also a list. Okay. For all practical purpose, that is also a list. How will you read? This is X. X dot shape. This is X dot shape. So if I want to read, this is 0 and this is 1. So I will read X dot shape at 0 and X dot shape at 1. Are we clear?
Okay.
Suppose you want to read first item, you will say at 0.
But it is
You
not
want to read, this is a square bracket 0, a square bracket 1. So suppose our list is 1, 5, 2, 9, 7. This is our list X. How will I read this? Can someone tell me? Tell me.
X of 3.
Very good. There is another way of reading. This is 0, 1, 2, 3, 4. You can also read -1, -2, -3, -4, -5. So I can also read as X of -2. Are we clear?
Yes.
Count this way or that way. Both are same. So I'm telling you 25, A, B, 69 and 70. I want last term. How will I get? Please tell me last term. X of -1.
-1.
Okay.
First term.
X of 0.
0.
Third term.
X of 2.
Rajesh.
Yeah.
You're silent. Any question?
I'm speaking. I don't know why. So are you able to hear me?
Yes, yes. No questions, Thakur. Able to understand.
Siddharth is silent. I'm sorry.
No, I'm also speaking in between.
Are we clear or not?
Yes, clear.
Yes.
Okay.
Question is like if it is a tuple, we should use the.
I told you whether I give this or I give a square bracket for practical purpose, it doesn't matter right now. So don't bother.
Okay.
That is why I told you, explain to you what they are. Okay. For practical purpose right now, it doesn't matter as long as you don't change it. So I want first to third.
1 to 0 to 2. Something like that.
X equal to this. So X equal to first to third.
1,
0,
0, comma.
0. Yeah.
Oh, colon.
0 to
3. 3. Because when you say 0 to 3, it means 0, 1 and 2. 3 is not included.
Yeah.
Okay. Do you understand?
Yes.
3 is not included.
Okay.
I want last 3.
Last 3 is -1 to -3, -4.
X
Yep.
minus
1 to -3.
-1, -2, -3. So we will start with -3 and we will end with
-1.
if I give -1, -1 will not be included, right?
Okay.
So we don't give any. This is sufficient.
Yeah.
Do you understand?
Yeah.
So this is Python I'm teaching you. And I hope it is very easy. So last two. Last two.
X of minus 2.
3.
Minus 1, minus 2, minus 3. So we will start with minus 2.
Minus 2.
And we will leave column and we will not give anything. Right?
Anything. Yes.
First 5.
0 to 4.
0 to
0 to
4.
6.
5.
5.
0, 1,
0, 1,
2,
2, 3. Yeah.
4, 5, 6.
6. Yeah.
Okay?
Right? First 5
5 is 4 only. First 5, it starts with 0.
Yeah, then it should be 0, 0 colon 4, right?
No, 4, then 4th will not be included.
Last will be excluded, right?
Yeah.
Are we clear?
0 to 4, 5.
You can write this. Rajesh, confused? See, let us start writing. It will be 0, 1, 2, 3, and 4. You see 5 items?
Got it. Yeah.
You can write this as shortcut also. First you don't give, that means it starts from 0 and this.
Okay, got it. Yeah, understood.
And you don't give, it starts from 0. When last one you don't give, it ends up to the last.
Last. Yeah.
Okay, got it.
If I take all, I can write, this is same as X.
Okay.
Clear?
So that we can print X itself, right?
Yeah, that is same thing, right?
Okay.
I take F5, 3, 9, 20, 25, 37, 8, and I want every third term. So I will say from here and I'll say 3. What I'm saying? From first to last, I did not give anything. Every third.
Every third. Okay.
So what I will get? 1, 9, 37. That's it.
It will start from the first two onwards. Every okay.
Because first two you did not give. So it will be first and it will be last. Right?
Okay.
If I give X 1, this and 2, can somebody tell me output?
1, 5, 9, 25, 8.
Everybody is clear?
Yep.
And if I give X1, comma, minus 1, comma, 2, what will be the output?
Certificate.
8.
5,
1, 2 minus last is 2.
5, 9, 25, and minus 1 will not be included.
Oh,
Are we
okay.
clear?
Middle time won't be included. Okay.
Are we clear about this?
Yes.
So our X dot shape is 5, 0, 6, and 13. This is rows and this is columns. Right?
Yes.
So how will we say rows? Can somebody tell me? X dot shape at
0.
columns. X dot shape at.
1.
Are we all clear or anybody has any doubt?
Clear.
And remember that this is number of weights everybody has to create. and that is also input in each row. Okay, and input we called feature. So I'm writing feature count equal to x dot save. Please write. I'm not giving you this code. 1. Are we clear?
Yes.
You people are going to write yourself. I'm not giving you that code. Okay. Print y dot save, run, and remember that this does not have any value. So I cannot take 1. So I write target count equal to 1. Because it does not have second dimension, so I'm not doing. Okay. Any question, anybody?
If the second dimension is not there, then okay,
Yeah.
it is one-dimensional array kind of thing, right?
We will have to write complex formula for that, but we know 506 records are coming.
Okay,
503 records are coming, and each has one value.
okay.
Okay.
It's a single dimensional array.
Yeah, I'm not writing because we can write formula, but at this point of time, you people don't know much of Python, so I wouldn't dare to do that. Okay, I want to make sure that you understand the features of language and you understand the concept of machine learning. Are we clear?
Okay.
Everybody done, or anybody has not done?
Done.
Okay, Gyan done?
Yeah.
Yes.
Okay, Rajesh?
Yeah.
Okay, good. So now you see, very important to understand, we have layers. Yes or no?
Yes.
506 records.
I have one question here. So on x dot shape, I could see some kind of a array of 6 dot some extension like exponential values, but for y I can see like a 24, 21, 34, something like.
Did not you get this value?
No. I got that value, but I am little bit confused with why y is not getting the y 506 comma
Well,
some.
because it has single value.
The other one x is also have single value, correct?
No, X has 13 values. It is based on housing data. So it has number of rooms, number of occupants. Okay.
Yeah, got it.
Area.
Okay. Got it.
Okay. And the Y is simply the price,
Okay.
one value. So you see how many, take example of one record, consider one record, not one record will come. Okay. So one record, when it comes, how many values are there? 13 values.
13 values.
So 13 weights plus one bias,
Okay.
right?
Yes.
Do you understand clearly?
Yes.
Yes.
Weights and these columns must match, right? And what we expect to get, 506 into 1. When it is not there, one value.
Mhm.
How many neurons I need in the end?
One.
One new.
Are we clear? Here
Yes.
we can have any number of neurons. Any number of neurons, but last must have one neuron.
One. Correct.
Clear or not?
Yes.
Good. So what we are doing? So feature count and target count, you people understood? Feature count will be the number of weights in first layer. Yes or no?
Yep.
We are not giving future count because this model is intelligent. This will automatically find out how many are there. Okay. This function you have to copy because I cannot explain you at this point of time. Okay. So this function you have to copy as it is. Okay, what it does I will tell you, but I cannot explain you beyond a point.
So the target count is not defined, is showing. So
Pardon?
for me, the target count is not defined. That's what is showing.
Okay, so you did not run that. See, you did not run this code. Did you run it?
Yeah, I ran the target count. It was showing 9. Target count is not defined.
Small c, capital C.
Okay, it is possible.
No, it's
Okay.
I define target count is 1. Okay.
Done?
Yeah, let me define it.
You people both are in QA. You should know that typo is the worst kind of thing. One typo took me around 36 hours to debug.
Yeah, it's working now.
Okay.
For me, I somehow the target count line was set as raw NB convert. That's the reason it is not working for me. I had to change it to code.
Now it, oh, sorry. Yeah, there are 4 types. Okay. This might be some shortcut you pushed. I don't know which shortcut does that.
Mhm.
Yeah, it is possible. So this is done. And this is what does it do? It says optimizer is a function. This is loss function and this is matrix function. Last one checks how accurate your prediction was. Suppose first 5 houses you take. Actual was 500, 200, 300, and your model predicted in first round 600, 300, and 250. So error it will calculate. You can give any error, but simplest is Euclidean distance. 100 square, 100 square, 50 square, and total is. This is the error, right?
It will be 10 square, right?
And this is 500, 600, 200, 300, 300, 250. Okay. This minus this 100 square, this minus this 100 square, this minus this 50 square. Minus plus doesn't matter, right?
Oh,
So why do we need to take square only?
Or because plus minus will cancel each other out. See, this is plus 100, this is minus 100, gone.
Okay, yeah,
Do you understand?
yes.
but
Long lead.
the difference is 10 only, right? There.
No, 500, 600. Oh, my handwriting might be why. 500, 600, 200, 300, and 300, 250.
But in the error, you are putting 100 square. 100 square is 10,000, right?
No, 100. 500 minus 600, how much?
100, but it will be 10 square, right?
No, error square.
Oh, error square. Okay.
Yeah, Euclid distance is that only. Delta x square, delta y square, delta z square. Right?
Okay. Yeah, that is the function. Okay.
Yeah. Now what happens? Second round. So it became 475, 225, 500. Again, it will calculate and it will say, see whether it is going in right direction or not. Do you understand? Again, it will go next round and it will check the error. Okay. So it will keep on checking error whether its error is minimizing or not. Do you understand?
Yeah. So
These are the self-feedback. Okay.
Okay.
These are the
Reinforced.
These are these three things. This also tells that I have stopped adding layer.
Your voice
Okay.
is echoing.
It's coming in.
Rishi, tell him mute your microphone. I'm not very sure. Can you people mute it?
Yeah.
Hello? Still echo? Now unmute and tell me. Still echo?
No, I don't hear echo from you.
Hello?
Yeah, now it is fine.
Now it's
Okay.
fine.
So anyway. So here you have
Hello. Did you lose your voice?
no. I was telling my son. Okay. So what happens? You see here. This says how will you calculate error? Number one. So that you can get feedback, right? How, what you want to optimize. Means what do you want to do? Cost reduction, whatever reduction. So that is these and these are closely related. And optimizer is, we will talk later what the optimizer is, not right now. I'll have to talk a little bit of mathematics. That will be only time I'll talk a lot of mathematics. Okay. And this also says end of adding layers. Do you understand?
Okay.
So basically this is that my construction of model is over. I still see some noise. Okay. You people, I hope it is okay. Okay. So far done. Everybody wrote the code.
Yep.
Now it is time to run it. Can you people run it and see whether it is working or not?
Yes, it's working.
Working?
Yeah, no error. Yeah, it's working.
Working? Result is good or bad?
It is working. No output.
You see, compare the prediction from machine and actual result. Actual price 19 is predicted as 4400.
We need
21,
to enter code.
yeah, prediction is bad. Yes or no? Do you see? Hello, everybody. You see
Yep,
what we did? What we did? We created last 10 numbers as X and last 10 numbers as Y, right? Last 10 houses. Just I told you what? Test X equal to of X. What we are taking? We are starting from last 10 and going up to end. Yes or no?
Yes.
And similarly, test Y is also same. So we are taking last 10 houses. These are features and these are prices. What I did? I told model, please go and predict. You see, I gave test X and I got the result. Yes or no? When comparing with result, what is happening? You see the difference. Huge or little?
It is not correct.
Correct or not correct?
Sagar, actually, I'm not able to follow this one because currently we have put this
You are
model.
not able to follow, right?
Currently, we
What
put
we,
model.combine and it runs.
what we did? We did training here, right?
Model.fit of x. I think I have to write that code. Model.fit of x.
Oh, you should have that code.
Let
You
me
are
check.
writing in new notebook or same notebook?
Same notebook. Okay, let me
Yeah,
check
but
it.
there is a difference between what we have, actually what you are running. That the reason we have a difference.
Okay, so let me give you something. Can you people write this one?
Model.fit
We
of
have model.fit.
You people write yourself because this is a small code. Can you write it?
Test is equal to yeah, 10 yeah.
Model.fit. Remember, this should be the code because first day we did this only. But anyway, model.fit.
so test x equal to 0 to 5. That's what you put. We need to put it x of -1, -10, right?
Pardon? The code is model.fit. It is for training. We are passing capital X and a small y.
Yeah. Yeah.
Done?
Let me do the coding. Result equal to dot.
Should I come to you?
Reject, okay.
Should I come to you, Rajesh?
No, I'm writing actually. Because I don't have that code.
Okay. Then you people write this. I think you people can write now.
Yeah.
I hope you people are not finding difficult to write code. Rajesh and Siddharth. Both are not speaking, so that means they are finding difficult.
I mean, like we are
I'm just updating like
updating the code. So can you scroll down a little bit? Like,
Go down. First, you completed these all.
yeah, I have completed until result.
We are just printing result and test y.
Okay.
Result is what machine told, and test y is what was the actual price. Yes.
I'm getting some error.
Okay. Who?
That's it.
Siddharth?
Yeah.
So I'm coming to Siddharth. Siddharth is there. Go ahead. Show me. Can someone guess the problem? Can someone show the problem? I don't.
Test x, right? So test x capital.
Test X he has done. He is passing test X.
I think the result equal to model dot predict of test x, right?
Oh, maybe the array which I gave right
Go
is less.
up, go up, go up.
Yeah, I got it. Test X was less, I guess.
No. Hold
The
on.
shape.
No. Hold on. Scroll down. That you don't have to change. Scroll down. Scroll down. Scroll down. Where you are creating test X. See, you are doing text X equal to what? 10 minus 10 colon. Minus 10 colon.
Yeah, colon should be at the end.
Oh,
So
okay.
that it goes up
Right.
to that.
Yeah.
And similarly, Y also.
Yes.
Run both of them again. Keep on running to down.
Yeah, it's working.
What do you see? Result?
Results array and t-type float.
Your prediction is far better than our prediction. Okay. And he's using iris data. Okay. Anyway, he's using iris data and we are using Boston data. I don't know about Rajesh. That's okay. You see, your actual value should scroll down. Scroll down, Siddharth.
Yeah. Scroll down.
Last two cells. Last two cells. Yeah. Stop.
Okay.
You see, the first prediction was 5.59, whereas actual value was 2.
Mhm.
The second prediction was 5.22, actual value was 2. So machine learning model was horribly wrong. Okay,
Correct.
Okay.
Yeah.
but that is not the point. Can I see Gyan and Rajesh? So I'm making you people presenter. And I want to see which data you used and what you did. So who first?
Okay.
Gyan,
Yeah, I'm sharing.
can you show me?
The main screen. Yeah. Can you?
Yeah. So go up. So
I'm using. Yeah.
which data you are using?
I'm using the Boston.
You are using Boston data, right?
Yeah.
That works. Can you just do? Can you do just Boston, load Boston to load iris and rerun?
Take
No,
out
no,
the iris.
yeah, not there. In the cell number 50. Cell number below that. Below that. The next cell where you are loading X and Y. Copy that cell. No. That is output. Yeah, copy that line and paste there itself. Paste there itself in same cell. Enter, and Control V.
Control.
V. Paste. Paste it there itself.
Okay.
Comment the first one. And okay, in Python to comment, you have to put hash. Yeah, first is commented. Second one, load Boston, make load iris. And rerun. Run. Run and see what is happening.
Yep. What is symbol? Okay, that's all right.
Keep on doing.
Yep.
So you got something? Okay. I'm coming to Rajesh. Rajesh, where you are? Yeah. Rajesh, can you share your screen?
Yeah.
So look, what we have achieved, we have changed from classical machine learning to deep learning model. It is working. It is not giving good result. Okay.
So
Now, you
currently
see,
I have ran Boston.
Scroll down. You see, the result is not good, right?
But how come we can know that this result is not good?
Hey, you see, first price is how much?
5,000.
Prediction is 5,000 and actual was 19.
Okay, got it. Yeah.
You see, that is correct.
No, that is totally wrong.
Okay, so go up and do load iris.
I have added this and then I
Uncomment and comment below. Yeah. Siddharth, can you also do that?
Yes, sure. We need to.
Should I come to you? Should I come to you?
Yes.
Okay, I'll come to you. And Rajesh, I leave him to do.
Okay.
He already has code. It is working. So what I showed you, we change the model, same data works. Okay. Go up where you are loading iris. scroll up.
Here.
Yeah. So what you are doing, loading arrays, comment that.
Yeah.
And run from 7 again. So run from above.
Yeah.
Start running, you will get the result. So in the meantime, what Siddharth is running, I want to tell you what we have achieved. What we have achieved.
For load iris, it is almost same.
No.
Not at least, but at least it's closer.
Two data sets are different, still your model is working.
Yeah.
Working.
Right?
Uh-huh.
We changed classical model to machine learning model and it is still working. Do you understand?
Yeah.
So I'm coming to my screen and let us discuss few things. Why machine learning classical model is doing better? Okay. Because classical model has some algorithm. Okay. How to find error, what is best, and so on. So deep learning does not have algorithm based on weights. That's it. So because we ran deep learning only once, it was not able to adjust weight. Do you understand? It started with equal weight. Here you see, it started with equal weight, and how many times we ran it? How many times it ran? Only one time. Yes or no? Hello?
Yeah.
We ran it one time.
Only one time. So what was the weight initially? 13 columns were there.
Yeah.
So weight was 113. 113, because it did not have any data, so it would start with equal weight.
Mhm.
So number of bedrooms, same weight. Tax bracket, same weight. Residential or commercial area, same weight. It did not have any difference. So it was giving you actually the average of whatever it had. Did you understand?
Mhm.
So that was the problem. So how to make it run multiple times? So I'm adding, and you people also add, epochs equal to 10. Now it will run 10 times. Do you understand? EPOCHS, epochs. It is worse than it was. Okay. If I do 100, what is going to happen? It is not working, right? You see accuracy is how much? 0.
0.
Something is horribly wrong. Okay. But then it tells you that machine model is working. Whether it is correct or not, that is different issue. Do you understand? From big values, now it became a small values. See, 8.58 e to the power minus 10, plus 10. This becomes bigger and bigger. Okay?
Yeah.
So our machine model is not able to predict. Are we clear?
Yes.
Why not able to predict? Because of this. Do you understand?
Because of only 2 layers.
Because our layers are not good. Okay. So let me go, and I have this same model. Okay. So I'm just trying to find out I have this or not. There is another model which I have kept, Boston Housing. So and you see what is happening. I'll go in the end prediction. So regression booster and so on and so forth. This is classical machine learning. I just want to see whether I have deep learning model or not. Okay. I doubt I have. So I don't have deep learning model. Okay. I have compared different models in classical machine learning. So I don't have deep learning for this. Okay. But what it shows you that I applied 4 different models available in sklearn. All are available in sklearn. Okay. And you will see all 4 are showing different result. Do you see? Yes or no? So what is happening? I have to come back to this. These neurons, the way we structured are not good, and we have to learn which type of layer, types of layers, perhaps more layers, 50 layers. Okay. So what I'm doing this. Let us assume that I'm doing this. I'm adding multiple layers. Okay, I'm repeating the same thing. Do you understand?
Yeah.
You people don't run because your server is not that capable. So after this, you can run. So I'm running. My server has 16 GB RAM. Your server has 2 GB RAM. So you can understand. So here you see what is happening. Something is model is not defined. So something went wrong. Oh, I will have to run from the beginning. And that's one. I don't want to lose earlier one. So I don't know which one is what. Okay. Accuracy and loss are not improving despite that. Okay. So I cannot do much. Okay. There's some problem. Okay. So it is not able to predict. Deep learning is based on simple weight method, and you have to put millions and billions of records. Is it better than classic machine learning? Any day. I'm going to show you next day how deep learning can perform better than classical machine learning. Okay. Only thing is, right now you have to remember that both models are working. So I have data 1. I can apply different model 1, 2, 3, and 4, and all can give different predictions. P1, P2, P3, P4. Right? If I want, I can change this to data 2. I can change this to data 2, and still same thing will work. Do you understand? I can remove this, I can bring model 5, and this will become prediction 5, it will work. Okay. So next day we are going to look into some of Python language. Whatever we have read, we need to understand what is function, etc. What is return type. And also we are going to first look at what is random forest. Right? So suppose you want to come to India, right? India. I realized that early 20th century, you know, there was a bus service from Calcutta to London to Calcutta. How many of you knew?
I don't know. I just came to.
There were, it used to take around 50 days. It used to go by road, not by sea. And that was sometimes the fastest mode of transportation. Around $138 or something was the charge, sterling pound. In those days, perhaps one sterling pound was monthly salary. Okay, 125 was monthly salary. So suppose you want to come from USA to India. So what you will do? Flight?
It wasn't
Yeah.
USA, it was Britain.
Pardon?
It wasn't from USA to India, it was from Britain
No.
to India.
Calcutta, London, Calcutta.
London, not USA.
No, not USA. They will come from USA. They will not go to London. My son is there. Okay. So what happens? Flight, yes and no. Catch flight? Yes or no?
Yes.
Yes.
No, then what you will do?
Stay in US.
Catch ship? Ship?
Mhm.
Yes or no? Right?
Yep.
Take bus service? Yes or no? Right?
Mhm.
This is a forest, a tree. Okay? This is simple model. And what does it do? Random forest creates small trees.
Mhm.
Okay. Tree model itself, it tries to predict with multiple ways. And that is why it is called random forest. That is also a tree method. Okay. Buy car. Enough cash? Enough savings? Yes. Buy. Right? No. Loan? Yes. Buy. Right?
Yep.
No. Take from friends? Yes. Buy. Right? No. Find something. Ask parents. Yes or no?
Mhm.
Classical machine learning model does all these things, not only this, but these things. That is why classical machine learning model gets you right results.
Okay.
But the problem with classical machine learning model is built-in algorithm. When somebody, see, why I love teaching kids? Because they don't have apprehension. Whatever I tell, they believe. Okay? If I tell you people, you will say Thakur doesn't know anything. Like I told you about that guy doesn't know quantum physics. It is possible that he knows quantum physics better than I know. And that is why he is telling that chicken and egg are only two superpositions of a system, right? It is possible. So I have preconceived notion and I cannot be convinced by that research paper. Similarly, classical machine learning models have some algorithm and that stops them from learning the way deep learning learns. 1968 or 69, there was a research paper which told that deep learning neurons cannot, they are called perceptrons, not neurons. Perceptrons cannot learn And for 30 years or so, 69, I think 59 to 89, there was almost no research in deep learning method because of that one paper, which told that deep learning cannot be a solution. Then 1989 came again that simple weight-based algorithm can lead to optimization. And now deep learning methods do not follow any algorithm except that they adjust weights. Like in real life, you have 5 friends, you depend on them equally, and then you have some need, and one person helps you more than other, you become closer to him. Another person ditches you, you go farther away from him. Next need you have, the person who ditched you comes helps you, he comes closer. What you do, you keep on adjusting your trust in your friends. Deep learning model is just that. Classical machine learning model has algorithm, and that is why it will fail in long run. A deep learning model doesn't have anything of its own, so it learns from anything. Okay, just you saw how deep learning model failed miserably. It didn't take off from 0. It was always accuracy 0. Okay, because it does not have any way to do something different. But does it fail? No. I'll show you Boston housing data also. Deep learning model does better than classical machine learning. But what I'm trying to tell you, classical machine learning has algorithm. Deep learning has simple algorithm based on weight. Okay, like so, say classical machine learning. Suppose this is the mountain. Okay, and you have to go from A to B. Okay. Deep learning model doesn't know. It tries to go this side, it tries to go this side, tries to go this side, and keeps on wandering till it reaches you. Okay. Classical machine learning model says that look, always go down. If this is up, don't go, come down. Do you understand? So classical machine learning model has always decided that it will go down. But suppose it reaches to a place where there is no road up, what will happen? Classical machine learning model will fail because it doesn't know how to go up, how to randomly walk. And deep learning model, because it does not have preconceived notion. Suppose you are trying to get a job. You are trying to get a job in particular technology, particular domain. If you don't get a job, what will happen? You will remain on, right? Suppose you don't have preference, what is going to happen? You might get your dream job someday, not immediately, right?
Yeah.
If you change millions of jobs, one day, 1 out of that million will be your dream job. Yes or no?
Yes.
In classical machine learning, you stop. You say, okay, I'm not getting that job, over. I don't want to do job. In deep learning, what happens? Okay, this job is there, I'll go and do. That job is there, I'll go and do. And someday you reach to that dream job. That is the difference between classical machine learning and deep learning. Okay?
Yep.
Could you apply deep learning always? No. If your problem is small, your data is less, classical machine learning will always give you better result. Okay?
Yeah.
If your data is huge, you have enough capacity, deep learning, always way to go. Okay, so any further question you have? Otherwise, we are going to meet on Monday. Okay? I'm going to put these
Monday?
things. Yeah, tell me.
Oh, we are not meeting tomorrow.
No, on Monday to Friday. Okay? If you are doing
Monday will be our Sunday, right?
Pardon?
Is Monday will be our Sunday, right?
If you don't want to do, then we can do tomorrow and then Tuesday. What do you want to do? Tell me. I don't have any problem doing tomorrow.
Tuesday, your Tuesday means our Monday, right?
Yeah, I'm saying, yeah, you will be, you want to do my Monday to Friday or your Monday to Friday?
Our Monday to Friday.
So we are going to take your class tomorrow. I'll not take your class on Monday.
Okay, that's fine. Because it will be our Monday to Friday, right?
Yes.
Okay.
Okay.
Yeah, that's what we discussed. Yeah.
Jan, are you okay with that?
Yeah, I'm okay with this.
Siddharth,
Yes, okay with this.
so tomorrow we are having class. We will not have class on Monday, Indian time.
Indian
Okay.
time, yeah, that's Sunday.
US time, Monday to Friday.
Yeah.
Okay.
Yeah.
Thanks a lot, everybody.
Yeah,
Enjoy.
thank you.
Thank
and
you.
Keep safe.
Have a good day.
Keep
Thank you.
safe because in India, the prediction is that by January, February,